In this AP exam review video, I want to take a little time and talk about density curves and the normal curve, and just very quickly kind of run through some calculator things. So first of all, density curves. What are density curves? Well, density curves are ways that we can calculate probabilities or percentages or percentiles using area. The normal curve is a perfect example of one. We often say, okay, between one standard deviation above and below, there's 68% of the data. It's because the area of the whole density curve is 1, and the area within one deviation of the mean is 0.68. Okay? So we use area to calculate probabilities or proportions or so on. Why do we use them? Well, it's continuous random variables. It's things where we can't say it's exactly like 5 out of 10 or something. We say, well, it's between this amount and this amount. So continuous random variables like the normal curve, where we have an average, we have a standard deviation, okay? And how we use them? Well, depending on the distribution, again, we use area. So there are a number of different density curves we've talked about. We've talked about the normal curve at length, but we've also talked about a t-distribution, right? You have a chart for that. We've talked about a chi-square distribution, and there's a chart for that. But we've also talked about just some kind of random distributions where you're given a little plot, and maybe you have to use geometry, or maybe you count squares or something like that in order to find the area. But it's always a matter of finding the area. And just a reminder, the entire curve has an area of 1 because the probability of any outcome in our sample space is 1, or the proportion is 1. The normal curve follows these kind of round values that within one deviation is 68% of the data, within 2 on either side, so plus or minus 1, plus or minus 2, and plus or minus 3. And just as a reminder, this is kind of those baseline points that we use. So when you're asked about a distribution, to describe it using that CUS, where part of that CUS reminder deals with shape, you shouldn't say normal unless you've checked at the very least these 3 percentages. So very often you'll say bell-shaped, or you'll say mound-shaped, or symmetric, or something. But to use the term or the phrase approximately normal, or even the term normal, you must have checked these things. So that's why we often say don't use that term, because unless you've checked that within plus or minus 1 deviation, 2 and 3, you're not allowed to say that it really is normal. Percents, percentile, what percent is below or above, I feel like we can deal with, and I'll talk more below. Percentile, just a reminder that percentile is always the percent below. Okay, I'm going to just make that. So this is always percent below. So if you're in the 90th percentile, that means that 90% of people were below you. If a dog is in the 45th percentile for weight, that means that 45% of dogs are below or way less than your dog. Okay? The z-statistic. The formula for z-statistic is our value that we're interested in minus the mean divided by standard deviation. Okay, so that's the formula, and very often we don't need to use the formula. We can use our calculator, but this is the z-statistic, and what it is simply is figuring out how many deviations away from the mean you are. So I'm going to just skip down to this example for a minute. The ACT has a mean of 20 and a standard deviation of 5. So if I said, well, what's the z-statistic for a person that scored a 30, and I'm picking an easy number for a reason, I would say 30 minus the mean divided by the standard deviation, that's 2. So what that represents is that this person that got a 30 is 2 standard deviations above average. And I know it's above because it's a positive 2. If it had been a 10 minus 20 divided by 5, that'd be negative 2. They're 2 deviations below average. Okay, so that's really what the z-statistic means. It's just, and sometimes it's called the standardizing score, but it's just how many deviations away from normal or from the mean are you? Okay, so that's the formula, but often we use the normal CDF and normal, we don't use PDF, but normal CDF and inverse norm. I'm going to show an example using my TI-83. The reason I'm going to use an 83 instead of an 84 is the 84 has a nice kind of fill in the blank, pattern to it, or fill in the blank menu. The 83, you actually do to kind of remember the format. So let's do this. We're going to figure out a couple of questions on the normal curve, and then we'll use the calculator for our example. I'm going to get rid of that. So let's figure out the proportion that is above 30, the proportion that's between 22 and 25, and the proportion that's less than 27. Okay, so we're going to calculate those things using the calculator. Okay, so let me just remind you where this stuff is. You go to distribution, so you'll press second, VARs, and you'll find normal CDF. That normal PDF, we're never going to use. Just forget about it, okay? So we're using this, and this is finding area. That's why we use it. We want to find the cumulative area. So I told the lower bound. I want to know from 30 and up. So remember, we use the 1E99. That serves as a 1 with 99 zeros after it, okay? And then we simply put in the mean and standard deviation, and it spits out that proportion that lies above 30. Okay, so if you'll recall, in our work, what we would have to do is we would do normal, 25, and we put a 30 right here and shade above, and then we would simply return that answer. All right, let's do on the calculator, let's do between 22 and 25. Okay, so let me, again, we should practice the appropriate work, so let's put our curve, normal, and really here we're just telling us what the settings are, and we're doing 22 to 25. Sorry that I'm a little sloppy there. And shade what we want. So again, what I've put in my work is I put the lower bound of 22, the upper bound of 25, the mean and deviation, and you can see it's 0.1860, I guess. So 0.186. Get my 8 a little bit better. And finally, less than 27. Well, let's once again draw our picture. I'll put it just below it here. Not a great normal curve. 25, and there's 27, 27, shade below. Okay, and please remember that is the work that's expected of you. Okay, and there it is, 0.919. All right, so now let's do one other kind of question. Oftentimes you might have to get the question of what score. Represents the 75th percentile. Okay, so let's draw that picture. Okay, how that would look is it's a normal setting, 20 and 5, and we are wondering, remember percentiles below, what score X represents 75% below. So this time we're going to use an inverse norm setting. We're going to tell the area below that we want and then the mean and standard deviation. It's in that same distribution menu you're going to go to, so nothing changes there, and it's actually just one setting down from what we just had. Okay, so here's the calculator work for that. Inverse norm, you can see the area below I wanted, mean, deviation, and it spit out the score, 23.37, which of course is not possible, so it's just 23 or 24, I guess. But that the 23 wouldn't get you there. A 24 would get you more than enough. but this is the way to kind of work backwards. Big things I kind of want you to focus on here. Think about density curves and the normal curve and what that means. Remember what percentile means and the calculator or the formula for Z statistic. Make sure you look back over these the ways to type these things in, so you recall that, and make sure you're looking at what kind of work we need. Remember, you need to draw, tell it this kind of the setting. It's normal, mean standard deviation, and then use your picture to say what you're finding. More than 30, between, and so on. Okay, so this is serves as a review of normal curves and density curves.